Welcome back to Algebra for Success. Today, we're embarking on an exciting journey into the world of graphing linear equations. Graphs provide a visual representation of the relationships between variables, allowing us to interpret and solve problems with clarity and precision. Let's get started. Graphing linear equations is like creating a visual map of the mathematical landscape. It allows us to see how one variable relates to another. We'll learn how to translate equations into graphs, which can be immensely helpful in various real-world scenarios. To graph a linear equation, we first need to understand the basics of linear equations. A linear equation typically has the form y equals x plus b, where y represents the dependent variable, x is the independent variable, m signifies the slope, and b represents the y-intercept. M is a critical often denoted as linear equations as it tells us the rate of change between the variables. It tells us the rate of change between the variables. If m is positive, it means that as we move from left to right along the x-axis, y increases, forming an upward sloping line. Conversely, if m is negative, y decreases as we move to the right, resulting in a downward sloping line. The y-intercept, symboled by b, is equally significant as it indicates the point where the line crosses the y-axis. This point corresponds to the value of y when x is 0, making it a starting reference on the graph. Now let's go through the steps of graphing a linear equation. Step 1. Plot the y-intercept. To start, identify the y-intercept, which is the point where the line crosses the y-axis. In the equation y equals x plus b, the value of b gives us the y-intercept. Step 2. Use the slope, which was symboled by m. The slope m indicates the rate of change between x and y. It tells us how much y changes when x changes by 1 unit. If the slope is positive, the line goes up as we move from left to right. If it is negative, the line goes down. Step 3. Plot additional points. With the y-intercept and slope, you can plot more points on the line. The slope helps you determine the next point. For example, if the slope is 2, that means for every 1 unit you move to the right, you move 2 units up. Step 4. Connect the dots. Once you have plotted a few points, connect them to create a straight line. This line represents the solution to the linear equation. Example 1. Let's work through an example. Consider the equation y equals 2x plus 3. To graph it, we first identify the y-intercept, which is 3. That is the point 0, 3. Now the slope of 2, we know that for every 1 unit to the right, we go 2 units up. So starting at 0, 3, we can plot another point at 1, 5. By continuing this process, we can quickly plot more points and draw a straight line. This line represents the solution to the equation. Example 2, let's explore a real-world scenario. Imagine you were on a road trip and your car travels at a constant speed of 60 miles per hour. The distance you have traveled, symboled by, depends on the time in hours, which is symboled by. This relationship can be expressed as the linear equation equals 60t. In this equation, the slope 60 represents the speed of your car and the y-intercept is 0, as when time is 0, the distance traveled is also 0. So as you drive, for every hour that passes, you've traveled 60 miles. We can use this information to plot more points on the graph. The line we create on the graph represents your road trip. The slope of 60 indicates that for each hour, you've traveled 60 miles. Here are 3 tips for success with graphing linear equations. Tip 1. Use the y-intercept. The y-intercept is a great starting point. It tells you where the line crosses the y-axis. Tip 2. Master the slope. Understand the slope. It indicates how the line behaves and its rate of change. Tip 3. Check your graph. Always ensure that your graph aligns with the equation you're given. It's a powerful way to confirm your work. Mastering the art of graphing linear equations opens up a world of possibilities for understanding and solving real-world problems. It's a skill used in fields ranging from physics to economics, making it a fundamental part of algebra. In our next segment, we'll delve into the intriguing world of polynomials, where we'll explore more complex algebraic expressions and their applications. Until then, practice your graphing skills, and remember, algebra is all about unveiling the mysteries of the real world. Keep practicing, keep learning, and you'll be well on your way to acing your algebra class. See you in the next segment.